Alright, so hello and welcome back to the continued coverage of the walkthrough series. And in this episode, we are looking at 9618 variant 43 of October, November 2023. And we'll be doing the Java implementation for question 2 of this paper. So let's go ahead and look at what we have. So the question starts with giving us information that we have a linear queue that's going to be implemented using a 1D array called Q, and of course the index of the first element is going to be 0. So we are to write a program code to declare the global queue with size of 50. It is going to store strings. Then we are going to have the head pointer initialized to -1. Then we're going to have the tail pointer initialized to 0. So we have to write program code to declare this global variable. So let's actually go ahead and look at that. Right there on lines 12 to 15. So you see that I have the global declarations right there from lines 13 to lines 15. Then what I did was, since the size of an array in Java arrays are immutable, meaning to say that once you create a Java variable, a Java array as it were, you are not going to change the size. So I just set the maximum size of my array to 50, meaning to say that whenever I want to refer to the size of the array, I don't have to use q.length, but I now just use the maximum size of 50. So this is why I have this private static variable right here. Basically, this is a constant in Java. So this is how you declare a constant in Java. So you're just passing that constant as an argument to as the size rather of the queue as it will. Then of course, you'll go ahead and copy this code and paste it inside of the evidence document. Moving on to item number 2, the procedure in queue does the following things. It's going to take a string parameter, then if the queue is full, it's going to output a message, maybe say something like queue is full. Then if it is not, then it's going to insert the parameter into the queue and update the relevant pointers. So we are to implement the enqueue function. So here I have my enqueue method right there going on lines 22 to lines 32 rather. So we are taking a string called item, then it's a void function because it doesn't return anything. It's just going to perform the code that is inside of its body. So the first thing that we need to do is to see if the tail pointer, right, is equal to 50. So if the tail pointer is equal to 50, it simply means that the queue is full. So we have to output a message that says the queue is full. Then otherwise, if it is not, then we are going to drop into this else clause. Then what you're simply going to do is you're going to take the item that was passed as an argument and store it inside, rather at where the tail pointer is pointing at, is it? Then if the head pointer was initially -1, was currently -1, we're simply going to point it to 0. Because remember that the head pointer, if it is -1, it simply means that there's nothing in the queue. Then when we enqueue an item, then it's going to move, it's going to be inserted at index position 0. So that's why we need to update the head pointer. Then of course the tail pointer is going it always points at the next available slot. So the tail pointer also needs to be updated accordingly. So that's what we're doing with the enqueue function right there. And of course, you go ahead and copy the code and paste it inside of your evidence document. Moving on to item number 3, we have the function dequeue. Essentially, it's going to dequeue or remove an element from the queue as it were. But then, of course, you have to remember that you cannot dequeue if the queue is empty. You cannot dequeue and there's nothing to dequeue as it were. So we need to implement the functionality for this dequeue function. So coming back to the implementation here, you see that I have the dequeue function again. This is going to return a string because remember our queue it's called it's going to be storing IDs of type string. So we need to take the element that is currently at the front of the queue, and yeah, that's how we dequeue it. So on line 36, we are simply checking to see if the head pointer is currently -1, or if the head pointer is equal to the tail pointer, in which case that would simply mean that the queue is empty, so we simply return empty. Otherwise, we are going to take the element that is currently in front of the queue and store it inside of this string item on line 40. Then of course we need to update the value for the head pointer so that it increments. Then after which we are going to check to see if the head pointer is equal to the tail pointer. This is after removing the element that is at the front of the queue. So if the head pointer is equal to the tail pointer, it means that there's nothing in our queue. So we need to set the head pointer to -1 and the tail pointer to 0. Then of course we end up by returning the item that we would have removed from the queue as it were. So of course you go ahead and copy this code and paste it inside of the evidence document. Moving on to part B, we have this text file called qdata.txt, and it's going to contain a list of game IDs. So the procedure read data is going to include the following thing. Basically, it's just going to read data from the queue into from the file into the queue array that we declared earlier on. So let's go ahead and look at that implementation here. So let's go ahead and look at the read data implementation right there. All right, so again, this is a void function, right? It just does performs the code that is inside of its body, then exits. So we start by creating a buffer data object on line 52, which is essentially going to allow us to read a text file. But then, of course, you need to remember that the buffer data object always takes a file reader object as an argument, is it? So that's what we're doing there on line 52. Then we declare a string called line, which is essentially going to hold our current line. Then while our line, we are using the reader object that we created on line 52 to read the current line and return that string straight inside of this line variable right there. So we are simply saying that while it is not equal to now, basically if there's something to read, we just want to take the current line, trim it, then queue it, rather pass it as an argument to the queue function. So this is going to repeat for as long as there's something to read from the file. Then of course we are using exception handling. File not found exception. This one is thrown by the file reader. Then the IO exception is thrown by the buffer data object. So you need to handle that accordingly. Then of course you'll be done with the implementation for the read data function. So you go ahead and copy the code and paste it inside of the evidence document. Then moving on to the next part of the question, we have part C. Some game IDs appear in the text file more than once. The program needs to store the total number of times each ID appears in the text file. So the record structure, record data has the following fields. So we are going to have an ID and a total. A string to store the game ID, then we are going to have total, which is an integer to store the total number of times that ID appears in the text file. So we have to write program code for the function record data. So let's go ahead and look at the function right there. So this is all right. So the way I went about this one was to, instead of creating a separate class altogether, I just created a static class right there. So in Java, you can create a static class. So essentially, a static class is best suited when you want to create, let's say, a record data structure, like in this case, right? And we are using this static class, and you see that it is inside of this question 2 and 23 v43 class, as it were. So essentially, it's going to save us the hassle of having to create a separate file altogether, because we're just going to make use of this class inside of this class. So static, that's how you can make use of static classes in Java. So we have that static class right there, and we have the string, which is going to be the ID, and the int, which is going to be the total. And of course, it's also going to have its constructor, which we are going to call whenever we instantiate an object of this particular class. So you go ahead and copy this code and paste it inside of the evidence document. Moving on to item number 2, we have the global 1D array called records. That's going to store up to 50 items of record type, of type record data. Then the global variable number record stores the number of records currently in the array, and it is initialized to 0. We are to write program code to declare records and number records. So let's go ahead and look at that implementation right there. So is my we want to do right. So let's go to the main method. That's where we should have implementation there. I will put my main method. I seem to find my main method here. All right, here's my main method. Wait. right? It's not within the main method, right? The online 18 to 19, that's where it is. So you see that we are declaring a record data, rather an array called records, and it's going to store record data objects, is it? And it has a size of 50. Remember when I said that you can just declare a constant, and you can always use that constant inside of your array declarations. Then on line 19, we have that number records variable, and we are initializing it to 0. So of course, you go ahead and copy this code and paste it inside of the evidence document. Then moving on to item number 3, we have pseudocode for this algorithm called total data, and it uses a dequeue to remove an item from the queue, then checks whether a record with a returned ID exists in the records, increments the total for that ID in the record if the ID already exists, creates a new record and stores it in the records if the ID does not exist. So we are actually given the pseudocode implementation for this, is it? So we are just going to translate this into Java code. Right? We are not doing anything special, just translating this to Java code. So already you can see that it's a void function because it's called a procedure, right? So procedures essentially are void functions in pseudocode. Then functions, for the most part, are going to be they are going to return something. So let's go ahead and look at the implementation for total data right here. There's total data. So it's a void function, as I did allude to earlier. So we are going to take a string, a variable called data accessed, and then we are going to dequeue it, is it? So that's what we are doing on line 77 there. Then if the data accessed is equal to an empty string, so we are simply checking to see right there if the data accessed is equal to an empty string, then we simply need to return return control to the main method, as it were, or just exit out of it. Otherwise, we are going to set the boolean to false right here, as they did right there in the pseudocode. Then we are going to use the loop to iterate through the number records, as it were. So int is currently equal to 0. Then the number of records that we have, that's how long our loop is going to run. Then we are going to be moving record by record. That's what this I++ means. So we are checking to see if the records ID is equal to the data accessed. Then we're simply going to increment the total for the records. Then we are setting found to true. Then we break out of the loop. Then we break out of the loop, as it were. So this is going to continue for however long the number of records are going to be. Then if we didn't find what we're looking for, that's what we're doing, saying on line number 91 there, we're simply going to create a new object of type record data, passing data accessed and the total to be 1. Then of course we are going to increment the number of records because we have added the records inside of the number records, inside of the records array, as it were. So this is the implementation for the total data function. So coming back to this, you would of course go ahead and copy the code and paste it inside of the evidence document for 5 marks there. Then we have another procedure called output records. Essentially, it's going to output the records, the ID and total of each record in the records format line. So we have the ID 1, 2, 3, 4, then the number of times it appears inside of the what? Inside of the records array. So we have to write program code for output records, or have it going on here. So essentially, it's just going to be use a loop to iterate through the number of records inside of the records inside of the records array. So we're using a for loop, right? That's going to run for however long the records is it. So essentially, we're just going to take the ID and output it right there, then take the total and output it right there. And of course, we're just concatenating with the strings there. New into this system there. All right, so of course you go ahead and copy the code and paste it inside of the evidence document. Next up, we need to call read data. Then we need to call total data for each element in the queue. Then we also need to call output records, right? So let's go ahead and code, make those calls inside of the main method. So what we are simply doing is we are calling read data, then it's going to populate our array way. Then we only want to total the data if the current object is not empty. So that's why we are using this while loop to say that while we dequeue an object and the object is not empty, then we simply want to call total data. So if the object is empty, we are not going to call total data. So that's what we are simply doing on lines 107 to 109 there. Then of course we also need to call output records. So we are calling output records on line 110. Then the final thing that we need to do is we need to test our program. So let's actually go ahead and do that. Let me just save the file, open the terminal, then I need to change my directory. And since I'm in the root directory, I need to move into this November 23 v4 folder. So let me just go ahead and do that. It's actually November 23 v43. So I want this, let me see if I can copy this. Can copy it. Okay, that's fine. So I want to run Java question 2 n23 v43 Java. Right. So hit enter. That should compile and run our program. So you see that queue is empty. Then we have the ID 1568. It's appearing a total of 1 time, and so forth and so on. So of course you go ahead and take a screenshot of this and paste it inside of the evidence document. So yeah, that does it for this part of the question. Hopefully you learned something, and I'll see you guys in the next one.